2024 GCE ADDMA paper 1 question 9. So find all the angles between 0 degrees and 360 degrees which satisfy the equation this. So whenever you have the modular signs, you always have two possible equations. So the first equation will be everything as it is, except that you remove the modular signs, or you can have sine x is equal to, you negate the number this side like this. So now you can solve these two equations and then list down the solutions. So to solve this one, remember these two are unlike terms, so even if I take this one to the other side, there is nothing I can do. So what we can do in order to solve this is to take advantage of the fact that tan theta is equal to cos theta, sin theta over cos theta. So you can just divide both sides by cos theta like this, cos x rather, and then cos x. So this into this will be a 1. Actually this is a tan x, and then this into this will be a 1, so we have a 2 this side. And then you can find your alpha by saying tan alpha is equal to the modulus of 2, and because this is positive 2, we have this. So before we go anywhere, we know that since tan is positive, this angle here must be in the first quadrant or the third quadrant where tan is positive. Remember this. Some people say cast, others say all scientists take chemistry. So tan is positive here since all the ratios are positive, and then tan is positive here since we have a t in there. So to find our alpha, we can say tan inverse 2. Our angle alpha will simply be the inverse of tan 2. And then this is, actually this should be in degrees. Make sure that your calculator is in degrees. So I'll change this to degrees. So tan inverse 2, this is 63.4349, correct to 4 decimal places. So to find the angle in the first quadrant, theta is equal to alpha. So the first theta is 63.4. You can round it off correct to 1 decimal place since this is final. And then to find the theta in the third quadrant, remember this is theta, this is alpha plus 180. So our theta will be 63.4349 plus 180. So when we add these two together, we get and the decimal part, we have the same thing. 3 plus 0, we have 3. 6 plus 18, we have 24. So this is 243.4349, which is approximately equal to this. Remember, angles in degrees must be rounded off correct to 1 decimal place. So we are done on this side. We have to solve this one as well, and fortunately for us, the procedure is still the same. So you can divide both sides by cos x, so that you get a tan. So this one here will be tan x, then this and this will go, you remain with this. So as usual, you start by finding tan alpha, which is equal to the modulus of this. So that means our tan alpha is equal to 2. So our alpha here will be tan inverse of 2, which according to this is 63.4349. And then to find the actual angles, you know that tan is negative. As you can see, this is negative. So this one is telling us that the angle is in the second quadrant and fourth quadrant. Why? Because only sine is positive here, so everything that is not sine is negative here, and then only cosine is positive here. So that means everything else, including tan, is negative. So the angle in here is found by using this equation. Theta is equal to 180 minus alpha. So this would be 180 minus, our alpha is 63.4349. So I'll use my calculator. 180 minus 63.4349, which is 116.5651. So when you round it off, you have 116.6 degrees. And then for the angle in the fourth quadrant, theta is given by 360 minus alpha. So you have 360 minus 63.4349. So let's subtract 360 minus 63.4349. So this will give us 296.565, which rounds off to 296.6. So now you can list down your thetas, starting with the smallest. So our smallest theta is 63.4 degrees, followed by the second smallest, which is 116.6 degrees, followed by this one, which is 243.40, and finally 296.6 degrees, and you're done.